Hi, I'm Gavin Uma, co-founder and CTO at K-Privacy, and today I'm talking about protecting sensitive data within web apps. So as developers, we have a responsibility to protect the data that we collect from our end users. Unfortunately, that's just really hard to do. It requires a lot of time and expertise to do properly. So today I want to walk through some of the technologies we can use to properly encrypt data, and also technologies we can use to securely process data. I'm going to walk through the typical journey that data takes throughout an application and through the cloud, and where the weak spots are and where data breaches tend to happen. And then finally, we'll design an architecture that's secure from the point that data is collected through processing in the entire lifecycle of that data within an app to keep that data confidential. And we'll walk through a simple JavaScript app that collects some data, stores it, processes it, and keeps it secure the entire time. So let's dive in. So when we talk about sensitive data, we're typically talking about things like names, addresses, and credit cards. But increasingly, it's binary data like photos, audio, video, documents, and things like that, which are really common to be processed with machine learning. And so within a photo or a document, there could be lots of sensitive information, right? So like faces or sensitive information in the backgrounds of photos, or sensitive information that's buried within pages of documents. And then, of course, as developers, we have a lot of sensitive data that we deal with as well in the form of secrets. So things like tokens for connecting to an API, or passwords for connecting to a database, or encryption keys themselves. So a typical application has a client-side app where data gets inputted. There's a load balancer on the edge of a network, which is distributing load across multiple backend servers. There's databases for storing the data, and then there's the disk underneath the database for persisting it. The weak points within this typically tend to be points where we're terminating TLS, places where we're processing data, and places where we're persisting data. So a client is probably going to connect to a domain over HTTPS. But the only assurance that gives us is that there's HTTPS at somewhere at the edge of a network. So usually a load balancer is going to terminate the HTTPS connection, which means decrypting the encrypted data, turning it into plain text. And so the load balancer has the plain text data that the client connected. What the load balancer should do now is establish a new secure connection to the backend server. But we really have no assurance as a client that that's happening. That's best practice, but we don't know for sure if that's happening. Then the backend server needs the data in plain text in order to process it. So this is typically where data breaches can happen, when a backend server logs data by mistake or prints data out somehow by mistake, and there's sensitive fields within those logs. So these are things that happen that just happen by accident. It's not even a sophisticated hack. Or somebody who has access to a database, and then there's plain text data within the database that they can view. And then a database should, when it persists the data on disk, it should use at-rest encryption. So if someone gets physical access to that disk, the data is still safe. So that's best practice, but again, you have no assurance that that's happening. So these yellow boxes can be solved with best practice, and these red boxes are a little more complicated, so we're going to talk about those as well. So first of all, what you should do is you should encrypt your data on the client, right? So at the point of collection, that's where data should be encrypted. And then where you send it, where you store it, it doesn't matter because it was encrypted on the client. Unfortunately, this just requires a lot of time to implement and a lot of expertise across different skill sets. And so as an individual developer, it can be quite intimidating to think about things like crypto algorithms and having to get your code audited, having to work with key management or establish key policies. It's hard to even know where to begin sometimes, and so it can be quite daunting, and it's something that we at CAPE aim to make easier. Even within large organizations, you have to set up multiple meetings, and it can take months, literally, just to encrypt some data on the client, because you need the SecOps team to create your key policy. You need your DevOps team to actually provision a key for you. Everybody needs to understand why, what are you doing, etc. What sort of keys do we need? Who needs access to the keys? What client are you encrypting on, and therefore what crypto libraries should we use? What algorithms should we use, etc. So it's a very long process to just even get access to a key to be able to encrypt data. And then when data is processed, and this relates back to the red boxes in our diagram, when data is processed, it's usually in plain text, right? And so this having data not protected in use creates major exposure points. And so there's a new technology called secure enclaves that allows us to protect data when it's being processed. So at CAPE, when we deploy secure enclaves, it's a highly isolated and constrained compute environment. So that means that the enclave by default has no network capabilities, it has no disk, and it has no interactive access. So an operator that has root has no ability to see within an enclave, to see in memory, or to see what the process is doing. There's no disk, and so if an application is logging data by mistake, it just gets logged out into memory, and then that memory is destroyed when the enclave is terminated. And so it's not persisted in any way. And then there's no network for somebody to be able to attack it from that angle. And so the way an end user connects into the secure enclave is through end-to-end encryption. So the end user will encrypt their data directly on the device, and then send that encrypted data directly into the secure enclave, and the secure enclave is the only thing that has the keys to actually decrypt and process that data within that isolated environment. So it remains protected and confidential even during processing. And this enables us to make encryption on the client side a lot easier as well, because the secure enclave itself is what manages the keys. So when you deploy a container or an application into CAPE Enclave, it automatically provisions a key for you. And so that enclave now has its own key that you can encrypt data for that can only be processed by that container. The policy states that only the enclave has access, so no human or operator is able to communicate with the key manager to do a decryption. Only the enclave can communicate with the key manager. And then finally, we provide a bunch of crypto libraries in various languages and for various platforms. So whether it's a mobile application for iOS or Android, a web application, or an IoT sensor that's collecting data, you encrypt directly on the device using the CAPE libraries, which are already implemented correctly and already audited. So with these technologies in place, we can have an architecture where the data is encrypted on the client side, and so intermediaries like load balancers, databases, caching systems, they don't matter anymore because the data was encrypted on the client side with a key for the enclave. And so the only way to process the data is to send it into the secure enclave and process it there. And so, you can send it, store it wherever you want. We like to say you can post it to Twitter, and that data is going to remain secure. So I'll show you a quick demo just on the CAPE Privacy website. So if you go to capeprivacy.com and click demo, you'll be able to do this yourself. So what we're going to do is just process a bunch of mouse movements and encrypt them. So the reason we're using mouse movements is because we can generate a whole bunch of them really, really quickly. And so here you can see the XY coordinates that are being produced as I move my mouse. And so those are the plain text values, but directly within the browser here, we're turning those XY coordinates into CAPE encrypted strings. So these strings can be taken and stored anywhere. They're secure. There's no network involved in this encryption process. We encrypt locally, it works offline, and it's really, really fast. So we've already encrypted, 1,100, 1,200 data points. And if we want now, we can process that data. So we're going to take all of that encrypted data, send it into a secure enclave. We're establishing a connection directly with the enclave, and now you can see a heat map of the mouse movements. And so the enclave generated this heat map from that encrypted data. The data points themselves remain completely confidential. So of course we're showing you mouse movements. They're not particularly sensitive in this case, but things like browser history could be very sensitive, and you could extrapolate this to sensor data, video, audio, or healthcare data, things like that, that can be encrypted directly on the device, stored in the cloud, and then processed within a secure enclave. So next I want to build a demo application in JavaScript. It's going to be a very simple design. We're just going to encrypt an image on the client side. We're going to store the encrypted image in MongoDB. Then we're going to deploy an image recognition model to CAPE, and we're going to run the encrypted image through that image recognition model. And so the encrypted image will be processed by the model within a secure enclave, and the image itself will remain confidential the entire time. So first, here's a quick example of the application working without CAPE. So I'll upload an image of a panda, and now this image was stored in MongoDB, and you can see that it's just the plain text base64 data. So anybody could easily view this image, particularly if they're an operator with access to the database itself. They can log in, query the database, and easily see that data. And so we don't want it to work that way. We want to encrypt the data before we store it. So I'm going to show you how to do that with CAPE. So first we're going to import CAPE. I'm using a code sandbox here, so I'll share this code with you. You can fork this. You can run it yourself directly in your own browser and get a feel for how it works. Next, we need to actually initialize CAPE. So here I'm initializing CAPE with my a token for a function, and now I need to encrypt the actual data. So you can see here we're just accepting the plain text data within our app. So we use a file reader to drop in the image, and then we just read the plain text image. We want to replace that with a cape encrypt call. So you can see I'm cape encrypting the image, and then this image data should now be the encrypted data, and then that gets inserted into Mongo. One more change here. Before we were reading the file as base64 data, and we want to switch that to bytes. And so we're going to accept the bytes of the photo directly and encrypt those. And then last but not least for this, we just want to include cape as a dependency for our React app. And so pretty straightforward. We just encrypt the image. The moment we drop it into the browser, we encrypt it, and then we upload it to Mongo, and then we read it from Mongo, and you can see that it's now encrypted. And so if we jump over to Mongo and refresh our collection, you'll see the second image that I uploaded was encrypted with cape. So I'll delete the first image because that was in plain text. So next we need a way to actually process the image. So for that I'm going to deploy an image recognition model. I have that model already built over here. You can view the code for the model yourself, but you can just assume it works and deploy it to your Cape account. If you want to view the code, it's all here on GitHub. Go to github.com/capeprivacy/functions. You'll see a bunch of different functions here. So I'm using the mobile net model. It's based on TensorFlow Lite, and you can view the code within app.py here. So you don't need to know any of that, but you do need to sign up for Cape to be able to deploy functions into secure enclaves. And so you can just click sign up on capeprivacy.com and then log in with GitHub, and then you'll be here. Copy this install script and paste it into your console. So now Cape is installed, and then the next thing you need to do is just log into the command line. So if you do Cape login, if you're not signed in with GitHub already, it will ask you to, but you're just confirming your device. And now, okay, so we're already logged in to Cape, so I'll clear this. If I type just Cape on its own, you'll see all the commands. The most important one is deploy, but also encrypt and run, or I should say those are the three most important commands. Now, if I run Cape deploy MobileNet, then it's packaging up all of the code that I showed you on GitHub. It's encrypting it and it's deploying it to the enclave. So this code itself will actually be remain confidential as well. So any secrets you have in the code, oftentimes machine learning models themselves are considered sensitive or proprietary, and so those remain confidential within an enclave as well. So you'll want to copy this function ID and bring it back into our code over here. And when we do a classification, we want to replace this with a cape run. So currently, our classification isn't implemented. It's going to be as simple as calling cape run and then storing the result in the classification. So we call cape run, and we'll use the function ID from the console. I just need to fix this variable. So there, the image data is what we're going to pull out of MongoDB. That's this value right here. So it's the cape encrypted string. That's going to be sent into cape and processed. So we can try that now. We'll try classifying this cape encrypted image. So it classified it as a giant panda. So I'll show you the image there. That was it. I don't know much about pandas, but it looks pretty giant. I have a cat image, so we can try that as well. I have all of these images on GitHub as well if you want to try these, but you can try ones just on the open internet as well. So here I added the cat image that got encrypted, uploaded to Mongo, and now I'll try classifying it. And so that got classified as an Egyptian cat. I'm not really sure. If we go back to Mongo now and refresh, you'll see the two images in there along with their classifications. And then we'll do a final image. This is Grace Hopper. It's a very famous image for machine learning models. And so if we go back now, we're classifying this image. I have to click classify. So now that encrypted data is being classified, and there's a 92% likelihood that it's military uniform, which seems pretty accurate. So that's pretty much just an off-the-shelf image recognition model. The important thing here is that we're showing how easy it is to collect data, even complex data, like images, video, documents, encrypt it, store it, pull it out of storage, and then process it in a fairly complex way while keeping it completely confidential. And so a database administrator or anybody else with internal access to the network has no ability to see that actual data. So in review, when we're sending the data to the MongoDB API, we're first client-side encrypting it, so it's protected over the network, it's protected in memory, and it's protected on disk. And then finally, when we want to process it, we can pull it out of Mongo. That encrypted image is sent directly into the secure enclave to be processed. And so we have end-to-end confidentiality, and we're providing a useful feature to our end user. So Cape, two main features: encrypt, run. The encrypt is really fast. It works on any device, any language. And then, of course, you can process your data within secure enclaves, keep your data, models, code, secrets, all confidential. And thank you very much. You can follow Cape Privacy on Twitter, follow me on Twitter, and please reach out if you have any questions, if you want to dive deeper into the security of all this and how it works under the hood. We'd love to answer questions or to help you out if you want to play around and build your own demo apps. Thanks. Bye.